Welcome to our YouTube channel. In this video, we are going to talk about limits. Before we start, don't forget to hit the like button and subscribe to our channel. Okay, so evaluate the following limits. Question number 1. A limit as x approaches 2 is this. Okay, now let's try to substitute where there is x by 2. Okay, so we'll have 2 squared minus 4 divided by 2 minus 2. 2 squared is 4. 4 minus 4, which is 0. So we'll have a 0 divided by 2 minus 2, which is 0. Now, when we are solving limits, we don't want such a situation to happen, especially with the denominator. We avoid a 0. Now, what are we supposed to do? Simple and straightforward. We are going to use factorization method to solve this problem. Okay, now, when we look at the numerator, we can see that this one, here we have a 4. Now, this 4 is a perfect square, which means it can be written as a square root of a squared number. Therefore, we are going to say, since it is a 4 and the square root of 4 is 2, therefore, we are going to say this one is exactly the same as x squared minus 2 squared over x minus 2. This can also be written again as x minus 2 in brackets and the x plus 2 in brackets over x minus 2. This one is just a difference of 2 squared over this one. Therefore, this and this is going to cancel. We'll have x plus 2. From there, we'll go ahead and substitute the value of x. So, we are going to have, since the value of x is 2, so we'll say 2 plus 2, which is giving us 4. Therefore, this can be written as a limit of 4 is as x approaches 2, or a limit as x approaches 2 is 4. Okay, let's go to the second problem. So on the second problem, we have a limit as x approaches 3 over x to the power 3 minus 27 divided by x minus 3. We can see that if we go ahead and substitute this x by 3, automatically we are going to have a 0 here. Even here we'll have a 0. Therefore, we use the same factorization method. We know that this is x to the power 3 minus this 27 can be written as the 3 to the power 3 over x minus 3. Therefore, this one can be written again as x minus 3 to the power 3 over x minus 3. From there, we'll go ahead and expand this part. Now, we know to say, if we have a situation which is a minus b to the power 3, where these are in brackets, is exactly the same as a minus b in brackets a squared plus ab plus b squared. So, since we have this concept, then we'll go ahead and use it here. So, here we'll have x minus 3, which is a minus b, open, a squared, which is x squared, so x squared, plus the product of these two, so which is 3x plus this one, which is 9. Okay, so because it is a squared, so it is 9. From there, we say over x minus 3. We can say that we have x minus 3 here, we have x minus 3. These two are going to cancel out. When they cancel out, we will remain with x squared plus 3x plus 9. Therefore, we'll go ahead and substitute now, because we know that we are not going to have a 0 down here. So, we are going to have a limit as the x approaches 3 of x squared, which is 3 squared plus 3x. So 3x, which is 3, plus 9 in brackets like that, which is equal to 3 squared, 9. So here we have 9 plus 3 times 3, 9 plus 9, which is equal to 9 plus 9 plus 9 as 27. Therefore, we conclude to say a limit as x approaches 3 is what? 27. Last problem. We have a limit as x approaches 0 is 1 over x, the root of 1 plus x minus 1 over x. We have this problem. Now, we know that if we go direct and insert the value of x, automatically we'll have zeros on the denominator. Now, we don't want that. Therefore, we are going to combine these two. How? This is 1 over x, the root of 1 plus x minus 1 over x. Therefore, we are going to look for the common factor here of this and this, which is x, the root of 1 plus x. This into this is 1. 1 times 1, which is just 1. X into x, the root of 1 plus x, which is the same as 1 plus x under the root, then times negative 1, which is negative root of 1 plus x. From there, we can say that this one is exactly the same as this one. Now, we know to say if we go direct and substitute the value of x here, we'll have a 0 as a denominator. But we don't want such a problem. Therefore, we are going to conjugate. So how are we going to conjugate? Let me just get this program to be here. Okay, so we are going to look for the conjugate of the numerator. Now, what is the conjugate of the numerator? It is this exactly value where we have a plus between here. So, we'll say multiplied by 1 plus the root of 1 plus x divided by 1 plus the root of 1 plus x. Now, this one is just the same as 1. So we are multiplying this value by a special 1. Because any value divided by itself is 1. For example, we have 1 divided by 1, which is 1. 2 divided by 2, which is 1. 10 divided by 10, which is 1. So here we have a special 1. Now, from there, let us expand. Let us expand. So we are going to have this multiplied by everything here, which will be just this. So we'll say we have 1 plus the root of 1 plus x. Then this multiplied by everything. So we'll have negative the root of 1 plus x, open the bracket, 1 plus the root of 1 plus x. Then we close like that. Over, we expand this by multiplying this by this. So we have x, the root of 1 plus x multiplied by this, which is 1 plus the root of 1 plus x. From there, let's see. Let us expand this numerator part. So we have 1 plus the root of 1 plus x. This multiplied by 1 is negative root of 1 plus x. This multiplied by this. So it is the same thing with a square root. So in short, we just remove the square root and leave out the values which are under that root. So we have, remember it is negative, so negative open bracket 1 plus x, like that, divided by x root 1 plus x open 1 plus root of 1 plus x. From there, we can distribute this negative. So negative times positive 1, which is negative 1. Negative times positive x, which is negative x. Therefore, in short, we have this removed with this one. Then we have again this part which will be removed with this one. Therefore, we remain with negative x on top there. So we'll have negative x over x root of 1 plus x multiplied by 1 plus the root of 1 plus x. From there, then we'll go ahead and factorize the negative x. Now, or we just say this x and this x will cancel. Therefore, we'll remain with negative 1 there. So we'll remain with the negative 1. So we'll have the root of 1 plus x open 1 plus the root of 1 plus x. Now, from there, let's go ahead and try to substitute. Where there is x, we put a 0. So we'll have 1 will remain just like that. So here we put a 0, we also put a 0 here. So 1 plus 0 is just 1. The square root of 1 is 1. 1 plus 0 is 1. The square root of 1 is 1. So we'll say 1 plus 1, which is 2. 1 times 2, which will give us a 2. Therefore, we know that when we do the substitution, we are going to have negative 1 over 2. Therefore, this will be considered to be our answer. Hence, we will write it as a limit as x approaches 0 is negative 1 over 2. Thank you for watching. Don't forget to hit the like button and subscribe to our channel for more videos.